Good morning, guys. Just doing a recorded class today, as I said. We're going to give this a go. I'm going to correct the homework. I'll probably have to split this into two videos just to keep the videos small, because when you're trying to process them and render them on YouTube, it does take a while. So we'll maybe what I'll do is I'll do a question doing the homework, correcting the homework 9, 10, and 11, and then do a couple of examples before setting homework. Okay. I was thinking about this, and I think the best way we can proceed is a mixture of live classes and pre-recorded classes. So what I was thinking, maybe, I know I was going to send out a form, and I probably still will, but I was thinking maybe that we could go a live class on Tuesday, a recorded class on Thursday mornings, and a live class on Friday afternoon, whenever I have you. Anyway, we'll discuss that again. Okay, so let's get started here on question 9. I'm just going to make sure I'm recording here. Yeah, okay, so guys, get your homework in. Remember, I am noting who's doing homework, who's attempting homework. I'm not even checking that much to see if it's right. I will at some point be checking that sort of thing, but for now, I just want to see who's doing their homework, who's trying. So get your work in, okay? I'll check it and I'll tick it off. A bag contains tokens of 3 different colors. A token is picked at random from each bag and its color is noted. That means it's written down, and it's returned to the bag. The experiment is done 100 times. Every 20th time, the relative frequency of picking up a pink token is calculated. So the graph shows results below. Okay, number 1 there. Estimate how many times a pink token was taken after 20 trials. Well, we can see there, that's 20 trials. That was the relative frequency of that 20 being picked out of the bag. And what they do there is, let's maybe do the answer over here, question 9. What they do is you just count how many times out of 20 that pink came out. You know, that's as simple as that. And that's how you calculate the relative frequency, which looks like to be 0.35, right between 0.3 and 0.34. So the relative frequency, let's write down that first. So relative frequency, actually, let's number this correctly and properly. Part 1. So relative frequency of pink after 20, so after 20 tokens were taken out, is 0.35. Now, to find out how many times does that mean that pink was picked in those first 20 picks. So 0.35 multiplied by 20. Get on your calculators. I have mine ready here to go. And we get 7. So that means pink was picked 7 times out of the first 20 picks. Now I can see after 40 trials, I can see that this increased. It's gone up to 0.55. So the relative frequency of pink after 40 trials was, it's up here, there, 0.55. That's after 40 trials. So multiply that by 40, and that'll give us how many times we actually picked pink out. 22 times. Okay, next one is after 80 trials. How many times was pink? It dipped again slightly this time. So after 80 trials, sorry, 80 trials. So it's this one. So that's 0.4. The relative frequency is 0.4. Relative frequency of pink after 80 trials is 0.4. Multiply that by 80, and that'll tell us how many times we actually picked pink out from 80 draws. 32 times. So pink was picked out 32 2 times after 80 trials. In your opinion, is there an equal number of each colored token in the bag? And give a reason for your answer. Yeah, so the relative frequency after 100 there was 0.45. Now, to me, it would, well, to find out, let's calculate the relative frequency after 100 trials. Okay, let's do that first. Relative frequency of pink after 100 trials. Let's go back to our graph to see what that is. So that's there. That looks like 0.45. Multiplied by 100, which means pink was picked 45 times out of 100. Geez, that's nearly a half. How many colored tokens are in this? Wasn't it 3? Let's go back and have a look here. A bag contains 3 different colored tokens. You know, you'd expect, let's go back to this whole thing about what you'd expect to happen. You'd expect that each one would, you know, out of the 3 would come out an equal kind of number of time, or nearly equal, relatively equal. So if you've 100 picks, you picked 100 tokens, and there's 3 different colors, you'd expect each color to come out 33 times for each color. Now we know pink came out 45 times, so how many other times is left? So 100 minus the 45, that leaves 55 times for the other 2 colors. And let's say they come out an equal number of time, roughly. So 55, if you divide 55 by 2 there, you'd be get like 27.5. So each color could come out 27.5 times. Now I know in reality you can't do that, but that's okay for maths. We can have a 0.5 like that. I'm going to compare that each color should have come out 33 times. That's what you'd expect, but pink came out 45 times. It seems a bit high. Going by what I see here, I think there might be more pink tokens. So do you think there's an equal number of colored tokens in the bag? I think there probably isn't. I think there might be a bit more pink. So that's, I think that there may be more pink. May be more pink tokens based on this evidence, or based on this experiment. Something like that will do nicely, guys. Okay, anything like that. But listen, part 1, 2, and 3, that's the bread and butter. They're the bits that we should be getting now at this point. Relative frequency multiplied by the number of trials. That's what that'll get your answer. Okay. So what I'm talking about is this, you know, these calculations here. You know, relative frequency by the number of trials. I want everyone to be getting those bits right. Okay, number 10. A spinner is spun 500 times and shows red 75 times. Okay, how many times would you expect it to show red after 1,000 spins? So we have to find out the relative frequency. So question 10. Let's find the relative frequency of the spinner showing red after the experiment. Okay. So it turned up, so relative frequency after 500 spins. That's the experiment. So it turned up a relative frequency of what? Relative frequency of red. It turned up 75 times out of 500. Okay, you can break that down if you want. Just put it on your calculator. 75 over 500, or 75 divided by 500, and that gives us 0.15. Or let's leave it as a fraction, maybe 3 over 20. 3 over 20. Then change that to decimal if you want, or you can leave it as a fraction. It's up to you. Okay, so that's the relative frequency. Based on that little experiment in question 10, the relative frequency of getting a red when you spin the spinner is 0.15 or 3 over 20. Okay, now it says here, how many times would you expect it to show a red after 1000 spins? Well, based on the experiment of 500 spins, we saw that the relative frequency was 0.15. If we were to roll that dice or spinner 1000 times, we just multiply the relative frequency of getting a red, multiply by 1000, and you will get 150. Okay, 150. How many times would you expect to get red? 150 times. That's it. Okay. So relative frequency, remember, is always based on an experiment. Okay, what happened in an experiment? What happened in that experiment is that red came up 75 times out of 500. So that gives a relative frequency of 3 over 20 or 0.15. Then we can use that information to project into the future. What if we spun the spinner 1000 times? So it would be 0.15 multiplied by 1000, which gives us 150 times that red would come up. Question 11 there. A card is drawn from a pack of cards, replaced and replaced. This is done 260 times. How many times would you expect? Now, we don't have a relative frequency here. Okay, the experiment has not been done yet. What we're going to do is talk about what we expect to happen. Okay, well, you should know your deck of cards at this stage. Remember what I was saying. Have a picture of a deck of cards in front of you. There's 52 anyway. That's the bottom part of our fraction, 52 for a lot of this. So how many times would you expect a black card? Well, half the cards are black. So that's your answer, half. That's your relative frequency, okay? How many times would you expect to get a black card? Well, like I said, 26 out of 52 are black cards, which is a half, okay? Now, it's done 260 times, so you need to get a half of 260, or just multiply it by 260, okay? So half it, or multiply by a half, or divide it by 2, whichever you want, 130 times, okay? That's part 1. Part 2, how many times would you expect to get a picture card? How many picture cards are there? Well, there's 3 in every suit, and there's 4 suits. So that's 12. 3 by 4 is 12 over 52. Okay, and that, what does that break down to? That's 12 divided by 52. So it's 3 over 13. Okay, now, again, a card is picked 260 times. So this time, getting a half of 260 in the previous question was easy. You just divide by 2. In this case, it's not as easy, so you have to multiply it out. Use your calculator. That's what it's there for. $260. 60. So we'd expect a picture card 60 times. Now the king of clubs, that's a very specific one. The king of clubs. Well, there's only one king of clubs. 1 over 52. We can't break that down anymore. Multiply that by 260, because we're drawing 260 cards. We are replacing them, aren't we? Yeah, it's important that it says that about it being replaced. So it's 1 over 52. 1 over 52 multiplied by 260, and that gives us 5. So we'd expect a king of clubs to come out 5 times. And the last one, a red ace. A red ace. Okay, so there's an ace in every suit. Now, 2 of those suits are red, the hearts and the diamonds. So there's 2 of those. I'm not even going to break that down. There's no need to break it down, you know, unless they ask really. Just multiply by 260. That gives us 10. We'd expect if we were drawing cards from a pack of cards 260 times, we'd expect that a red ace would come out 10 times. Okay, so that question was very much about predicting the future, predicting what would happen. So that's why we were talking about expected, what would you expect? In the other questions, we were talking about the relative frequency. We were talking about an experiment that had already been done, using that like relative frequency to predict the future then. Okay, so there's our 3 questions, and I'll pop this video I'll pop the video up in this space here, and it'll explain those questions. Okay, and now I'll stop this and I'll do a separate video for with examples for today.